Let me find you another circuit from my list of circuits. Let's see if I can find another circuit. Okay. Now, here's another circuit. Let's see with this circuit if it will give us something tangible. Okay. Now, you have got, I want you to do this with me. And then here, let's say 3,9 kilo ohms. And then let's say this one, which is your R2, let's say 10 kilo ohms. And then this one, your R1, 62 kilo ohms. And then your VCC, let's say 16 volts. This is your VCC. Okay. Now, step one. Let's analyze this circuit. Let's analyze this circuit. Step one. Anyone who can tell us what must do in step one? Just unmute and then you say it, then we move forward.
Test the stiffness.
Okay, we check the stiffness, which means we're going to say R in base, R in base will be given by beta DC multiplied by RE. R in base, beta DC, is 80. RE, which is 680, which gives you what?
.4 kilo ohm.
54, 4
kilo ohm.
Kilo ohms. Are you sure?
Yes.
Yeah, it's correct.
Okay. 54,4 kilo ohms. Good. Then from there, 10 times R2, which is what? Which is 10 multiplied by R2, which is what? Your R2, which is 10 kilo ohms, which gives you what?
Hundred kilo ohm.
100 kilo ohms. Are we together so far? Okay. Now, once we determine this, then we need to compare the two. We need to compare 100 kilo ohms and 54. Now, is R in base greater than 100 kilo ohm?
No.
No.
Which means your transistor is not what?
Stiff.
Not Steve.
It's not stiff. If your transistor is not stiff, which means now your VB will be a VB of what? R in base parallel, which means this one is giving us not stiff. R in base is parallel to R2 divided by R in base parallel to R2 plus R1, all of this multiplied by VCC. Are we together? Are we together so far?
Yes.
Yes.
Okay. Now, then from there, what must be the next step? I need to find what is R in base parallel to R2, right? What is R in base parallel to R2?
It's 8,447.
8,447 kilo ohms. Is that correct?
Yes, sir.
Okay. Which means it's going to be 8,447 kilo ohms divided by 8,447 kilo ohms plus 62 kilo ohms. All of these multiplied by what? VCC. What is your VCC? 16, which gives you what?
One comma 919.
1,919
919.
volts. Did you all get that one?
Yes, sir.
Okay. After we calculate VB, what must we calculate again?
We must calculate VE.
We must calculate VE. When you calculate VE, which means now VE will be given by VB minus VBE. Now, VE minus VBE, which is what? Which is your 1,919 919 minus your VBE, which is what? 0.7, which gives you what?
1,219.
1,219 volts. Are we together up to so far? After VE, what must we calculate?
IE.
Okay, now we calculate IE. IE will be your VE over RE. VE over RE, then it is going to be what? It is going to be 1,219 divided by RE, which is 680, which gives you what?
1,792 milliamps.
Eh?
1,792
1,792
milliamps.
milliamps. Okay? Then after IE, what is the next step? After IE, what is the next step?
We calculate I base.
We calculate I base.
To compare if it's equivalent or not. IE is equivalent to IC.
Now, we check if in the statement where we given that we must assume if IE is equivalent to IB or IE is not equivalent to IB. Sorry, we check if IE is equivalent to IC or IE is not equivalent to IC. Now, those are the conditions that they must be given to us. Do you understand the chart? Those are the two conditions that they need to be told to us. They need to give us the lead direction. If it is not giving the lead direction, which means we will assume if they don't say anything at all. I want you to listen to me very carefully. If they don't say anything at all, then you go and assume that IE is equivalent to IC. If they don't say anything at all, they don't put it in writing, this assumption, then you will assume that IE is equivalent to IC. Now I want us to look at this in both ways. Let's say they don't give it to you. If they don't give it to you, which means now we will assume that IC is equivalent to IE. Do we understand the chart? Now, therefore, I will go and say IC is equivalent to IE. Now, with this IC equivalent to IE, then it's going to be equivalent to 1,792 milliamps. That is the assumption that I am making because it was not really given to me. But if it was given to me, it was going to be a different story. If it was given to me, it was going to be a different story. Now, because it is not given, it's not said, then I will make that assumption. It's either it is said or it is not said. If it is not said, this is what we assume. But if it has been said, what did they say in that statement? Oh, they say IE is equivalent to that one, which means I must follow this direction. Or they say IE is not equivalent to IC, which means I must follow that direction. Now, if that is what it is happening, then you'll go and say, now I need to see this. Now, when I do this, then I will go and say, wait, I'm just trying to check something. Okay. Now, because they said it, because they never said it, then I will have to follow this route. When I follow this route, what is going to happen? Now I will say, let me find what is VC, because I have determined IC according to the equivalency of IE. VC will be given to be what? Will be given to be VCC minus ICRC. Remember, this equation comes from VRC, this equation that you see here. Then from there, what is VCC? VCC is 16 minus ICRC, which means 1,792 milliamps, multiplied by RC, which is 3,9 kilo ohms, which gives you what? I'm waiting for the answer. I'm waiting for the answer. Hello?
It's 9,011.
9,001.
1, yeah.
11 volts. That is your VC. Now, after you find my VC, then I will say, let me determine what is VCE. For me to determine VCE, then I will go and say my VCE, it will be my VC minus my VE. What is my VC? It's 9,011. What is my VE? It is 1,219 volts, which gives me what?
7,792 volts.
7,292.
792. 792.
792 volts, like this. Okay, now I have done this analysis here. Once I do this analysis, now remember, this is when IC is equals to IE. Are we together on that one? We are working on this condition. Are we together on that one? Hello?
Yes, sir.
Good. Now, if we are not on this condition, now we are on a condition whereby now we are assuming that IC, it is not equivalent to IE. This is assuming that IC is equivalent to IE. This is assuming that IC is not equivalent to IE, which means we must find what is IB, right? And for us to find IB, what must happen? IB must be IR1 minus IR2, isn't it? Now, how do I find IB? This is the equation, which means I must find IR1. How do I find IR1? How do I find IR1?
VCC minus VB divided by R1.
It will be VCC minus VB divided by R1. What is VCC? It's 16 minus what is VB? VB, it is 1,91, sorry, 1,919 divided by RE, which is 62 kilo ohms, which gives you what? We're trying to summarize here. So work with me on this one. We are trying to summarize.
It's 227,113 micro.
200 and
227.
227.
Yeah. Comma 113.
112.
113
What?
microampere.
What?
So I asked money.
Oh, Lulu.
It's
120.
227,113 micro amp.
113 micro amps. Then
So I asked it's VB over
after IR1, what must I do?
Get to IR2.
IR2. And how do I find IR2?
It's VB over R2.
R2.
BB divided by R2. Now, in this case, what is your VB? Your VB we have determined to be 1,919 divided by, then 919 divided by R2, which is what? 10 kilo ohms, which gives you what?
191,9
191,9 micro amp.
191,9
9
micro amps.
amps.
What is IB? We are summarizing. We are summarizing now. What is IB?
is 35,213.
35.
Yeah, 35,213
35,213
microamperes.
micro amps. Once we find IB, then we can find what? We can find IC, isn't it? And then for us to find IC, it is going to be beta DC multiplied by IB. Beta DC 80 multiplied by 35,213, which gives you what?
2,817 milliamperes.
2,817
Yeah.
milliamps. Okay. Once we find beta DC, then we can find what is VC. What is VC? It's going to be what? Your VC will be your VCC minus your IC RC. VCC 16 minus this one, which is 2,817 multiplied by 10 to the exponent minus 3 multiplied by, which is milli, multiplied by RC, in this case, which is, where are you? 3,9 kilo ohms, which gives you what?
5,0114.
5,014 volts. Okay. Up to so far, are we together? Can you see? This is when IC is equivalent to IE, and this is when IC is not equivalent to IE. This is what we got. Now, I'm going to remove this, put it aside. Then from there, once we get these, now let's see if these will work within the collector characteristic curve. Now, first I'm going to do both of them, which means I'm going to say condition when IC is equivalent to IE. That is the condition. Now, what is your IC in this case? What was your IC in this case? What was your IC in this case? Work with me. Work with me. Remember, your life depends on test 3. Work with me.
Sorry, sir.
Yes. What is the problem?
So we only like here when IC is equivalent to IE.
Eh?
We here when IC is equivalent to IC, when it is assumed that IE is equivalent to IC. Yeah. We only
What?
do calculation for that part only, or we include even when it is not assumed.
No.
Or here you are just showing us two.
I'm showing you two conditions. One condition is if they don't tell you that IC is equivalent to IE, which means you assume that if they don't tell you anything about IC and IE, you will assume that IC is equivalent to IE. Do you understand that part?
Okay, I understand.
Now, if they tell you, you must just follow what they tell you. Now, I given you two scenarios whereby IC is equivalent to IE, and when IC, it is not equivalent to IE. It doesn't mean if on the test I asked you, when you just have to give me both. No, you need to give me the specifications. Do you get what I'm saying?
Thank you. Yeah, I get it.
Okay. What is
Thank
IC?
you.
1,792 milliamps.
1,792 milliamps. Okay, that is your IC. And then what is your VCE? What is the VCE that you have determined?
7,792.
7,792 volts. That is when IC is equivalent to IE, right? Now, to see that it is with regard to the collector characteristic curve, to see that this, it is with regard to the collector characteristic curve. Then we are going to say, let us find cutoff. Let us find saturation so that we can see if it is active. Do we understand each other on this part? Now, for us to do that, for cutoff, then we are going to say for cutoff, what are the conditions? Remember, we need to find these. Now, for cutoff, what are the conditions? Then we go and say IB is equals to 0. When IB is equals to 0, IC also is equals to 0. Are we together on that part? If these both conditions, they exist, if these both conditions, they exist, then your VCE is equals to your VCC. Now, this is equals to 16 volts, which means you are at what? You are at cutoff. Am I making myself clear? Am I making myself clear? Good. Then, now you can go and say, I have determined one part of the collector characteristic curve. What is that part? That is the VC part. VCE part. Remember, it must be VCE and then it must be IC. Now, with this VCE, now I've determined the cutoff, which means that is the maximum voltage from the collector, your cutoff, which is 16 volts. Remember, this is your VCE at a point of cut off. Am I making myself clear? Good. I hope so. Now, once we're done with cutoff, then we go and check the saturation point. How do we change the saturation point? If I say to you, for saturation, you must assume that VCE at saturation is given as 0.2 volts. We are assuming that the saturation voltage, it is given. If the saturation voltage it is given, which means now we are going to say, for me to find I saturation will be given by VCC minus VCE at saturation divided by RC plus RE. Are we together so far?
Yes.
Good. Now, if this is the condition, what is VCC? VCC, it is 16 volts, isn't it? Minus V saturation 0.2 volts divided by RC. What was our RC there on the circuit? RC, it is 10. No, not 10. 3. What is RC?
3.9 kilo ohms.
Oh, 3.9. 3.9 kilo ohms plus 680 ohms, isn't it? Which is what?
Three
3,450.
3,450.
450. What?
Milliamps.
Milliamps. That is what? That is the saturation. Now, that is the maximum current that this transistor can work. That is the maximum. that this transistor can work, which means here as my I saturation, I've determined this is 3,450 milliamps. That is my saturation point. Then I must join saturation together with cutoff. When I join the 2 points, which means that is my DC load
line.
Thank you. Now, then from there, now I need to go and check. Remember, this part here, that is my cutoff region. This part here, that is my saturation region. Do we understand each other? Now, then from there, now we go and see. It's IC greater than I saturation. It's IC greater than I saturation. Is the question?
No.
It is not greater than I saturation, which means your transistor, it is not at saturation. Can you see? Now, then you will go and say, now your I set, it's less than this one, which means I can say my I set, let's say, for example, it is somewhere there, which is my 1,792 milliamps. It is there, which means that is the point at which my current is. Am I making myself clear? Do you understand what I'm doing here?
Yes.
Now, at this point, which means if I go down, I will find my VCE. What is your VCE? Your VCE is what? 7,792. This point here where your saturation and your VCE cuts or meets at a DC load line, that is your operational point. This is what we call your quotient point. Now, therefore, I want you to listen to me very carefully. Therefore, this value that you see here, this is your ICQ, and this is your VCEQ. It's your VCQ, it's your ICQ. This is your operational point. Then you will see that your beta DC, if you were to look at your beta DC, you will see that your beta DC, it will be somewhere moving along this line here. Because it start operating at 0.7 volts. This is your IBQ. Questions? Any questions? Nothing. Good. Now, that was condition 1. Can you see that is when IC is equivalent to IB? Yes, sorry, your IC is equivalent to IE. Now, the same thing, when IC, it is not equivalent to IE. What is your IC that we have determined in that part? Hello?
2,817
2,817.
milliamps.
817 milliamps. What is your VC? E?
You didn't calculate.
Are you sure?
Yes.
3,795.
Eh?
3,795.
Or you take the liberty of calculating. Okay, you can calculate VC E on that part. I think I just forgot to. But you can calculate VCE on that part. You said it's what? 3,71795
795.
or 795. You can calculate VCE on that part. Where I stopped at VC, you can just go and say VCE will be given by VC minus VC minus VE. Then you will find this 3,793, ne? Or am I right?
3,795.
Oh, 3,795. Thank you. Volts. 3,795 volts. Now, you have got this one, this one. Now you have to do the cutoff. Now you need to do these three regions: cutoff, saturation, and active. What will be the cutoff here? Your V cutoff here, it will be what? It is going to be what? 16 volts, right? Are we agreeing on that one?
Yes, sir.
Okay. Then we draw the collector characteristic curve, which means at that portion there, that is where your cutoff region is. Then this is your VCE, and that is your IC, which means a cutoff, I can say, is at that point there, which is 16 volts. That is your VCE cutoff. Okay? Now, if I'm not given the condition of VCE set, which means I will assume that VCE set is what? It's 0. Now, find I set. Find I set. Find I set. VCC minus VCE set divided by RC plus RE. Now, if I'm not given this VCE, which means I will take it to be what? To be 0 volts, right? If it's not given. I am not told about anything about VCE set, which means I will take it that that value is what? It's 0. But if I was told, it was going to be assumed that this one, it is equal to that one. But because it was never set on this condition, which means I will leave it as 0. Now, if I'm leaving it as 0, what will be your I set? Quickly, what will be your I set?
3,493.
Eh?
3,493.
3,493.
Milliamp.
3,493 milliamps, right? Which means somewhere there, I will say this is 3,493 milliamps. Then I join the 2 points, which is your saturation and your cutoff region. What have I determined? My DC load line. Now, after I determine my DC load line, then I go and check. What is my I set? I set is what? It's 2, it's less than. So my IC, it's less than my IC set, which means it's somewhere, for example, here, which is 2,817 milliamps, somewhere here, which means if I draw the line, it's going to cut somewhere there. Are we agreeing on that one? Then if I go down here, then my VCE is going to cut somewhere here, which means that will be at 3,795 volts. Now, if I draw this correctly, which means that is my saturation region. Now, when this graph grows, it goes like this. That is my IB. Now, this is my quotient point. Can you see that now everything is working within the active region? It's above the saturation, it's below the cutoff, which means it's on the active region. Now, if it's on the active region, which means everything or your transistor, it is operating. Now it can start amplifying, it can start working as a switch. Now, then because this is the quotient point, which means that is your VBQ. Now, here, then you have got your ICQ, and here you've got your VCEQ. Then you are done with your analysis. Any question whatsoever?
Sir,
Yebo.
can you please do the ICQ point and the VCQ point?
Eh?
My network is bad, so the screen is blurry. So I wanted to get the part of the ICQ. Like, where do I get to place the Q on the graph? The ICQ point.
Okay. Did you understood this part, the first ICQ? Or you didn't understand anything that has got to do with the collector characteristic curve?
I understand how we get to draw it. I just don't know where to put the Q now. How do I know? Good, okay, now I have to put the Q here on the IC. Where, on which one? Exactly. I don't know if I'm making sense.
Okay, let me just repeat what I said, because your question is, I'm not understanding. Okay, your IC, the value of IC that you have calculated on the equation, when it is below your I saturation, remember, if you look at this, can you see this is your IC? Can you see this IC here? Or your skin is still blurred? Can you see this IC here?
The one we calculated, yes, sir.
You can see this IC. Now, this is the IC we have calculated from the equation. This is the I saturation, which means that is the maximum current. Now, when you compare the two, you will see that saturation is bigger than this one here, which means this value falls within the point of 0 up to maximum. It falls in between. Do you understand that part?
Yes, sir.
Then I will go and say, for example, if maximum is 3,4 there, which means I can say below maximum, I can go and put this 1,7 volts there. So 1,792 milliamps, somewhere here. Do you understand that part?
Yes, sir.
Now, if I extend this line in perpendicular, so in parallel to my VCE, which means I draw it in this manner from here. If I trace this line going there, you will see that at some point it's going to cut your load line.
Yes, sir. I've noticed that.
At that point where it cuts the load line, that is your Q point. Does it make sense?
Yes, sir.
Now, if I go down parallel to your IC, if I go down parallel to your IC, you will see that from the DC load line, if I draw a line going down parallel, which means it's going to cut at a point of what? At a point of your VC. It will be in between. Remember, here it's your 0,7 volts, and this is your maximum, which is your cutoff, which means in between here, that is where you find your operational point of VCE at 7,792. then you will see that joining this point and that point at that Q point, which means this is your operational point or your quotient point. Then you go back to your IC and IQ, sorry, IC and VCE. Then you say these two values, because they fall within the scale of the operational point or of your collector characteristic curve, then which means those are your quotient point. Then you just go and say, which means now this is my ICQ and now that is my VCEQ. Simply means that they're operating at that point there. Do you understand what I have done there?
Yes, sir. Thank you so much.
Okay. Any question before we close the session?
So, sir,
Yeah.
everything that you labeled here in this curve, we must also do it.
Eh?
Everything that you labeled in this curve, we must also label it in the test.
Yes.
Okay, sir. Even the DC load line.
Even there?
Even the DC load line.
Oh, how are you going to define your operational point if you don't tell me your DC load line?
Aye. Ngiyakuzwa manyara.
Thank you. Anyone else?
Sir,
Yep.
okay, let me ask ne. Let me say on the graph ne, I did mention, oh, okay, fine, this one is a Q point. Then I didn't go to that part, yeah, to mention go like this one is ICQ and VCEQ. Is it okay, or I have to go and mention them?
Remember, which means now you are interpreting the graph inside your working. You understand what I'm saying?
Yes, sir.
You are interpreting this graph inside your workings. Or the value that I've determined there, it falls within this, which means it is defined into the graph as this part here, which means when I see ICQ, then the moment I see this ICQ, then I can go to the relate to the graph as well, which means that the quotient point, which means that is the point, that is the point.
Thank you, sir.
Okay. Next question.
Are you gonna give us the formulas?
Eh?
Are you gonna give us the formulas?
But you said I must stop giving you formulas because they confuse you.
No, they don't, sir.
No, sir, give them to us, manyara.
Okay, I will summarize the formulas, but you must know these formulas by head.
Sorry, sir.
I will give you the summary of the formulas, but you must know the formulas by head.
Sir, I have a question.
Yeah.
So, sir, if like condition 1, which means we need to do the first part that we did of the characteristic curve, which is IC is equivalent to IE when we are doing condition 1.
Eh?
Like if we are doing condition 1 where IC is equivalent to IE, we need to do the first part. And then like if you are doing the second condition where is not equivalent to IE, we need to do that second part that you did, sir.
Yes.
Okay, thank you, sir.
You're not talking about the graph. Again, you're talking about the calculations.
Yes, I'm talking about the calculation. So, like after the calculations, we need to do this, like that graph that we did for that particular condition.
Yeah, you need to follow the remember, this and this is the same thing. This one and this one is all of this is the same thing.
Yes,
there's
sir.
nothing different between this one and this one. There's nothing different. How you calculate how you plot your graph is the same condition, which means It doesn't matter if IC is equivalent or it's not equivalent. It doesn't matter. This is the same. The only difference between this one and this one, it was the fact that here I assume that V saturation is 0.7 volts. Here I didn't assume anything.
Yes, sir.
On the test, I can say to you, here on this one, it's 0.2 volts. Do you understand what I'm saying?
Yes, sir.
So read the information given so that you don't mislead yourself. But say on the revision class, remember on IC is not equivalent to IE. You never gave VCE set. No, VCE set can come in any way. Am I making myself clear?
Yes, sir.
Yes, I can say to you, VCE set is 0.2 here on this condition, which means the equation, you will see that this equation and that equation is the same. The difference is the substitution because of the assumption. There's nothing different between these two equations. I just want to make that point clear. There's nothing different between these two equations. The only thing, here I assume, here I didn't assume. It doesn't mean if I didn't assume, always it stays like this. No. I can say to you, assuming that your VCE set is 0.1. Is it making sense?
So one of the condition will be given.
Yeah?
One of the condition will be given.
What do you mean one of the condition will be given?
Like say use IC is equivalent to IE. Ohm.
Or
like ohm, we only gonna do the part IC is equivalent to IE.
Don't try to spot my test because you will have a problem. Now, you have got this condition. You have got first condition when you analyze is the stiffness. That is condition 1. Condition 2, it is what? It is your, remember your stiffness comes with their own equations. Condition 2, now it is your IE and your IC, which means you have got IE is equivalent, so it is not equivalent to IC, or IE is equivalent to IC. Can you see condition 2? Can you see another condition? And yeah, talking to you. Can you see another condition? Condition 3. I C E saturation is given or not given. These are the conditions. Does it make sense?
Yes.
Good. Next question. Before we close, we're almost 10 minutes after. Yes.
Okay, before we close now, can you please go back to the graph for the first circuit that we did?
For the first?
The first graph that we did. That one that we find like our VCE is negative.
Yes.
I want to know like if we found like our VCE is negative, you said that we're not gonna have the graph. Huh?
Yeah, well, how are we going to plot the graph?
Okay.
Remember, that's why I said now you guys are making me angry now, which means you're not listening. Guys, I said to you, where's that paper now? But I said to you, remember, IC and VCE must have a relationship between these points. Can you see these points? Ma'am?
Yes, sir. Okay.
Can you see these 2 points?
Yes, I can see.
The moment one of the two goes outside these points, which means there is no DC load line that will be cut at that point. Does it make sense?
Yeah.
Eh?
Yes, sir.
Good. Anyone else? One last person. Going once. Going twice. Okay. Thank you very much for your time. I can see on my list only 25 people and you're 160 something who are supposed to attend. I don't know about the rest, or what are they doing and what are their mission. But well, I hope they've got their own mission. Remember, you need test 3. Now your life depends on test 3. So whoever thinks that maybe by miracle, I don't know, maybe Easter miracle will get them to pass, then I don't know about that one. Anli, thank you very much for your time, and we really appreciate you staying with us up until 10 o'clock to do
No
this
problem.
for the students. Okay, guys, I hope this will help you a lot, and you can go back and refer so that you can prepare for tomorrow, for Thursday's test. Tomorrow I'm not available at campus, so don't ask me on the group, are you at campus? No, I'm not at campus. I'll come at campus Thursday morning, and then if you've got any question Thursday morning, I will be there at campus. You can come and ask if there's something that you don't understand, but go through this, and I hope and I pray that Thursday's test will get you to qualify for the exam. Okay. Anli, you can stop recording and then upload it for them on Vutela. Thank you very much and
I will
good
do
night.
so.
Thank you
Okay,
very much and
bye.
good night. Bye.